Morning students. Last class we have discussed about the transport of oxygen and transport of carbon dioxide and their reaction as well. Today we'll discuss about the regulation of respiration and the disorder of respiratory system. So how the respiration is regulated? It is actually we can say neural. It is controlled by the neural system. So how it is controlled? Now, human beings have a significant ability to maintain and moderate the respiratory rhythm to suit the demands of the body tissues. Means if the body tissues need oxygen, then they will increase the inspiratory rate. If the body tissue needs to remove the CO2 from the body, so expiratory rate will be increased. So this is actually a, we can say, rhythmic process, and this rhythmic process is controlled by a neural system. How it is? A specialized center present in the medulla of the brain. All of you know, in the brain, hindbrain, pons and medulla and cerebellum, three parts are there. So here the medulla region of the brain, they are actually having respiratory rhythm center. Okay, what is that? Respiratory rhythm center is primarily responsible for this regulation. Another center present in the pons region of the brain called pneumotaxic center can moderate the function of the respiratory rhythm center. So in the medulla region, respiratory rhythm center is present, and just in the pons region, just above the medulla, their pneumotaxic center is present. This pneumotaxic center is controlling the function of this or rhythm of this rhythmic center. Okay, neural signals from this center can reduce the duration of the inspiration and thereby alter the respiratory rate. Okay, a chemosensitive area is situated adjacent to the rhythm center. Rhythm center ke in the side of the rhythm center, one chemosensitive area is there, which is highly sensitive to CO2 and hydrogen plus ion, H plus ion, and CO2 if it is increased. So definitely that area becomes sensitive. Increase of this substance can activate this center, which in turn can signal the rhythmic center, okay, to make the necessary adjustment in the respiratory process by which these substances can be eliminated. So first of all, the adjacent to the rhythmic center, there is a highly sensitive area which can sense the high amount of CO2 and H plus ion. जब भी उसको ये सेंस हो जाएगा, दे आर पासिंग द सिग्नल, सेंडिंग द सिग्नल टू व्हिच वन pneumotaxic center, and then pneumotaxic center control which one? Rhythmic center. Okay, so now it is coming. So these are the way it is going on, and this, we can say, increase this substance can activate this center, which in turn can signal the rhythm center to make the necessary adjustment. In the respiratory process by which this adjustment substances can be eliminated. Okay, now it is coming. This is about which one? It is present in brain. Now some aortic arch and carotid artery that is present in a heart, that is also, there also receptors are present, and that also can recognize the changes in CO2 and H plus concentration and send necessary signals to the rhythmic center. So there also receptors are present who are actually receiving the information that CO2 and H plus and increase. So they will send the message to rhythmic center. Rhythmic center can take the necessary steps to control it. The role of oxygen in regulation of respiratory rhythm is quite insignificant. So here, how the rhythmic center is actually working. Now they are actually, we can say, the increase is the substance. They are actually making the necessary adjustment. Here it is given, can moderate this function respiratory rhythm center and duration of the respiration. So neural signals from this center can reduce the duration of the inspiration and thereby alter the respiratory rate. So this way they can actually proceed. So you can see here how many processes are there. You can, if you, I'm drawing one that is a little bit brain structure, and here you can see that is actually the, we can say, cerebrum portion is here. So you can see here cerebrum portion. I'm not drawing in details here. So now if we are coming up the midbrain, and then we are actually passing this, so this is actually about the, we can say, about the all these things are coming, and now we are coming about the pons as well as the medulla. Okay, so this one is we can say about This is pons and medulla, and here cerebellum will be present there. Okay, so cerebellum will be present there. Now I am coming to the point ki this one is the medulla portion. Pons is, if we are thinking about the pons, is this one, and this one is medulla. So here in the medulla, the rhythmic center is present here. Okay, these are the rhythmic center, inspiratory and expiratory. So this is actually a rhythmic center, and they are controlled by, in the medulla, again a pneumotactic center is there. So it is coming pneumotactic center is present here, where in the pons this pneumotactic center is controlling which one. This is controlling the rhythmic center. So say that the duration of inspiration will be controlled, and as well as the if CO2. So they are sensitive. On adjacent also the sensitive area is present, which is actually sensitive to which one? Increase of CO2. They are increase of CO2 and H plus ion concentration. So they, when this become active, when the CO2 and H plus ion increase, so they become active. When they become active, they are actually, this pneumotactic area is actually controlling the rhythmic center. So they are passing the signal to control the rhythmic center, and rhythmic center control which one? Now the respiratory rate, to remove that CO2 and H plus from the body, and next one to adjust this CO2 and H plus from the body. And next one more is there in the heart. It is coming about the carotid arch, and one more is coming about the aortic arch. So aortic arch and it is artery. And these two in the present in the heart, they are also sense which one? The high amount of CO2 as well as the H plus. So they are sensing that, and when they are sensing this one, they are actually passing the signal to respiratory rhythm center, and this rhythmic center again control this, we can say all this respiratory process actually, to remove or to adjust the normality. So this is the way by which the regulation of respiration is going on. Okay. Next one, we are coming for the disorder of the respiratory system. Asthma is the difficulty of breathing. So three types we have to discuss here. First one is the asthma, second one is the emphysema. So asthma is the difficulty of breathing causing the wheezing due to the inflammation of bronchi and bronchioles. तो एक coughing होता है, wheezing होता है, and due to the inflammation of bronchi and bronchioles में inflammation से ये irritation आते हैं और itching आते हैं, that is called the wheezing. Wheezing means coughing in a very wheezing sound, and that is called difficulty in breathing. That is called asthma. Emphysema is a chronic disorder in which alveolar walls are damaged, due to which respiratory surface is decreased. So what is the symptom of this? The respiratory alveolar walls that will be damaged, due to which respiratory surface is decreased. One of the major cause, this is the cigarette smoking. Okay, so due to cigarette smoking, the alveolar walls will be damaged, and due to that surface area will be decreased. So exchange of the gases will be decreased there. That is called the emphysema. And next one we are coming for, that is occupational respiratory disorder. Occupational means due to occupation in certain industries, especially those involving the ग्राइंडिंग, किसी को स्टोन को ब्रेक करना, स्टोन को ग्राइंड करना, ये सब जो फैक्ट्री होते हैं उसमें जो काम करते हैं, दे आर एक्चुअली सराउंडिंग बाय द डस्ट एंड ऑल, दे आर ऑल्सो इनहेलिंग द डस्ट ऑल्सो. So much dust is actually produced there, and this dust is entering in their lungs. So long exposure of this type of dust, if their persons are exposed very long time, that can give the inflammation, and that is actually called the occupational respiratory disorder. So I am coming to the point again, the defense. So much dust is produced that the defense mechanism of the body cannot fully cope with the situation. Long exposure can give rise to inflammation leading to the fibrosis, that is the proliferation of the fibrous tissue, that is called fibrosis, and thus causing the serious lung damage. Workers in such industry should wear the protective mask. That is the solution actually. So due to the long exposure to the dust or stone baking, the inflammation is arising in their lungs due to fibrosis, that is the proliferation of the fibrous tissue. मतलब बहुत ज़्यादा बढ़ जाते हैं fibrous tissue की, proliferate हो जाते हैं, thus causing the serious lung damage. So workers in such industry should wear the protective mask. So these are actually the we can say the disorder of respiratory system. So this chapter is over today. And if you have any doubt, you can ask me regarding any portion here. Especially these portions are very important. Transport of oxygen, transport of carbon dioxide as well. This the exchange of gases where partial pressure is increased, decreased. This one where the partial pressure is more, where the partial pressure is less, and everything that in the table already have discussed so many times. And because of the where the partial pressure is more, from there where the partial pressure is less, that will be going. And so these are the condition. Just say PO2 104 here, PO2 here it is coming 40, so definitely it will be coming, oxygen will be coming, and CO2 is 45 here and CO2 is 40 here, so definitely it will be going from the capillaries to where the alveolar air. In that way everything is written here. What will be the PO2 in, it is 95. जब ये ऑक्सीनेटेड हो जाता है तो PO2 क्या हो जाता है 95, PCO2 45, और यहाँ पे क्या हो जाता है डीऑक्सीनेटेड मतलब CO2 जो टिश्यूज होता है, टिश्यूज में 40 और 45 होता है, ऑक्सीजन कितना 40, तो और यहाँ पे ऑक्सीजन कितना होगा PO2 इक्वल्स टू 40 एंड PCO2 इज कमिंग हेयर 45 टिश्यूज में, तो PCO2 45 और यहाँ पे PCO2 40, मतलब कैपिलरीज में PCO2 40, सो डेफिनेटली 45 to 40 में जाएगा. नाउ ऑक्सीजनेटेड ब्लड विल बिकम CO2 रिच ब्लड, है ना, और यहाँ पे PO2 40 और यहाँ पे जो लेके आया है ब्लड इज ऑलरेडी कैरिड आउट बाय दिस ऑक्सीजनेटेड ब्लड वेसल्स है, सो इट इज 95 millimeter Hg और यहाँ पे इट इज कमिंग 40, टिश्यूज में 40, सो 95 to 40 it will be coming, means from the higher partial pressure to lower partial pressure the exchange will be going on, and due to which one, due to that diffusion process. All of you know gas exchange is occurring by diffusion process. So जहाँ पे high concentration उधर से जहाँ low concentration there it will be providing or that will be proceeding. And now again here it is 40 and 45. कहाँ पे 40 45 ना, ये जो CO2 rich blood तो 40 45 से कहाँ पे जाएगा ना 104 and 40, तो 104 ऑक्सीजन इधर है तो यहाँ पे ऑक्सीजन आ जाएगा, तो now this CO2 rich blood will become which one, oxygen rich blood. Okay, so just go through the chapter very properly here. This is the respiratory volume as well as the respiratory capacities, बहुत ही important है, बहुत बार आते हैं ये definition, and they are actually the amount also. So go through it. If any doubt you have, you can ask me. I am giving you the question answer also after.